Hello, my name is Dave Dietrichs, and this is my submission for our Week 2 assignment for FTH 212 Striker Fired Pistols. So in this past week, we assembled the PSA Dagger. The first prompt was, what were some safety procedures that I used while preparing to assemble this firearm and assembling this firearm? Well, I wore eye protection. Obviously, I got my glasses on now, but I had safety glasses over top, and then I had a face shield just because springs can shoot back, and I don't want to lose an eye. I wore rubber gloves. Just I didn't know whether there'd be oils or you know pre-manufacturing oils, that type of stuff, and I kept a clean working area because I didn't want to lose any of the parts. What tools did I use was the second prompt. So I used a few different style flatheads. Here's one of the flatheads I used. I'm not going to demonstrate every tool I used, otherwise I'd have a whole table worth. I used a brass plastic hammer that was provided to us. I used a ball peen hammer, brass punches, roll punches, those are different punches. I used needle nose pliers, and I used paper clips to help with trying to feel around, get stuff aligned. My prompt 3, my readiness. Do I feel like I could work on a Glock platform? Not efficiently. I'm going to say that now, not very efficiently. Could I do it? Yes. I mean, I was able to assemble this within. It probably took me 2 hours. I'm not familiar with the Glock platform, or the PSA Dagger is technically a Gen 19, but I'm not familiar with their internals, how they work, so I would say I'm going to need more practice before I can confidently say that I could do very time efficient professional work on this style of striker fired pistol. Then the final prompt for the first part was, what tools do I feel would made this better? Having more specialty tools, really, or maybe something better to put the sights on, because I know that we were provided with the front sight little tool, which was just a hex head. A little socket would work, but it was nice having that. Didn't have to hunt a socket down. I also like that we had that driver. So I don't know if Glock makes any more specialty tools to make assembly and disassembly a little easier on their firearms, but that would have been nice to have. Alright, so moving on now. So demonstration piece. So I have the PSA Dagger. So before we do anything further, we're going to do a safety check. So first, slide it away, and as we can see, nothing's in the chamber, so we're going to lock it back. Once again, I'm going to stick my finger up in there. I don't feel anything, and we have daylight. So the firearm is clear and safe. So demonstration, so right now we're locked back. If I was to load a magazine into it, so let's say I load a magazine, and I slide this forward. So we're doing a functions check. I would have technically have fed around, and right now we're locked. So we're locked. So when I go to pull the trigger, we would fire. So the striker would protrude out and would hit around. From there, because this is a blowback design, it would force the firearm back. And while doing that, we would eject, or we would unlock and eject around, and then we would repeat the cycle all over again. As we can tell, the firearm does function. Pull the trigger. I'm able to lock it back. The trigger was pulled again. So there we go. Functions check. It does function, and I do believe that was an alright explanation of the cycle of operations for the striker fired pistol. So next, we were asked to measure the barrel length of the firearm itself. So I'm going to go ahead and slide this forward, because to measure the barrel length, we are to measure it against the breech face. So this has to be pushed in the battery. So next I will grab, I have a rod here with a blunt tip. So now I am going to insert said rod, and I already marked it earlier, just it's hard to do with two hands. But I'm going to slide this till I hit the breech face. And I have a scratch mark there from earlier, but what I did is as close as I get to the face of this, I'll do it again a little bit. Let's see if I can't. I don't want to damage the finish here. So I'm just making a little line that I can read. Okay, and now I'm going to set the firearm down. It's right here. So next, what I'm going to do is find my mark again. There it is, and we're going to take a measurement. So we have, let's see here. So our measurement is like right at 4 inches. So our measurement is right at 4 inches. I do believe this might be just a 4-inch barrel or not. Let's take one more. Let's be sure here. Yeah, so to the crown, 4 inches. So we have a 4-inch barrel. So I'm going to put this back and that back. Now for our final prompt. Discussing a shorter barrel's twist rate versus the longer barrel's twist rate. So the longer barrel will actually have a shorter twist rate than a shorter barrel. Shorter barrel will actually have a longer twist rate, like a 1 to 10. A longer barrel will have something down to like 1 to 7. And this is due to, because of the length, you need that bullet to continue to spin faster, or be able to spin, because you want to stabilize that bullet as it flies through. Because of the shorter barrel, and you only need to twist so much, that and much shorter barrels, the grain of the bullet is actually heavier than some high-powered rifles. That's not always the case, but that's what I found from research. I went on AR15.com forum. I mainly went on forums. That was the one where I found the most information, and it was just a forum labeled barrel twist rates, and I read through it and found information that way. But it seems that everyone agreed on there that the longer the barrel, the shorter the twist rate, the shorter the barrel, the longer the twist rate. But this concludes my week 2 assignment. Thank you for listening, watching, and I'll see you in the next week's assignment.